Alright, let's look at 9.1, polar coordinates. Let's go over a little bit first. What we've been doing the whole time, and you've been doing for years and years, right? Using a rectangular coordinate system, which means you locate points given a distance x and a distance y. Right, so let's say I have a point 3, 2. Right? You can call it P for point. Well, how do you graph it? You go on a Cartesian coordinate system, which is an x and a y. Go right 3, up 2. That's your point. Alright, so just to locate a point using x's and y's. That's what a Cartesian coordinate system is, right? Rectangular. Let's look at polar. So we're going to do polar coordinates now. I no longer locate a point with distance and distance. Now I do it with distance, alright, which is the r value, and direction, which is an angle, a theta. So this r is distance, and this theta is direction. Let's see how that would work. So let's say I have a point, it's 2 and 30 degrees. Alright, so to do a polar graph now, we just have the same t pretty much. Alright, now let's start with the angle. The angles are just like your unit circle, everything we were doing in chapter 5, 6, and 7. This is 0 degrees, 90 degrees, 180 degrees, and 270. So that'll take care of the angle. Alright, now the r value, right? On polar coordinate systems, an r is just a radius. Right, so given a radius and a direction. So go out 1, 2. So label your r's. So now each one of these points, it's not just a point, it actually maps out a circle. Alright, so every one of these is a circle. Alright, so 3, if I kept going, I'd have, these are just concentric circles. So now what we're saying, it's easier, I think, to graph the angle first. So go 30 degrees. That's my 30 degree line. So I want to go where 30 degrees intersects a radius of 2. Well, 1, 2, go to P, or a point. So that's my point right there. Right, 30 degrees and 2. Alright, piece of cake. Well, let's try, actually, since it's a distance, what if I had a negative distance? Alright, well, if I had a negative angle, let's try that too. I would just graph it as a negative angle. And if this was negative 30, I'd graph down here, I'd go out 2, put a dot. So negative angles are the same as you've been graphing regular angles. Alright, let's think about negative distances though. Okay, so let's look at, how about a point that's negative 2 and 30 degrees. Alright, so let's do this 0.1 and 0.2. Alright, so now if I had to graph this point, negative 2 and 30, right, here's my 0.1. I do the same thing, I graph the angle. So graph the angle. And if you picture yourself standing at this origin, right, you're going to face the angle that you draw. So I'm going to face in the 30 degree direction. Well, the 2 means you go positive 2, right? You step out 2. You go towards your point, right, or your angle. Negative just means, right, you don't go forward from the origin, you step backwards. So I go 1, 2, backwards. Right, and that'd be my new point 2. Alright, so positive means you step in the direction you're facing. So if you were literally this point here, or on the origin, you turn 90 degrees or 30 degrees, you'd step forward for 2. If it was negative, you'd step backward for 2. Alright, well, this is 30. I actually know what this angle is. It forms a straight line. Right, so it's 180 degrees. Right, I'm going to add 180. So this is going to be angle of 210. Right, so I take my 30, straight line, because I have to walk in a straight line backwards to get my negative point. Alright, see how this works a little bit. Alright, so I'm going to graph these 4 points. Kind of have a sketch here of the polar coordinate system. Alright, it's a little light sketch, so I'm going to fill in the part that I'm going to use. Right, I want this. And I want this. Alright. And the other ones are just, they're kind of a light graph here, because they're not really there until I graph my points, just for a reference. So I'll fill out my 0 degrees, I'll fill out my 90, I'll fill out my 180. So just like I'd fill out a Cartesian, I gotta fill this out. Well, each circle I'm going to label as 1. Alright. You have to label your concentric circles. Right? Label your tick mark still. Because just like a regular XY, these could go by 5s, they go by 10s, they go by 100s, right? No big deal. Well, we have the same one I just showed you, so 2 and 30, right? So go 30. The tick marks here, the actual lines are broken up into 15 degrees. So if you don't like that, you can just do general like I did before and graph your own. So this would be a 30 angle right here. Alright, so I want to go to 30, so 230. That's my point A. Alright, okay, now how about negative 3, 5 pi 6? Well, if you don't like 5 pi 6, change it in degrees. 180 divided by 6 is 30. 30 times 5 is 150. That's 150 degrees. Alright, so again, if these are by 15s, this will be... that'll be my 150 mark right there. Alright, so I graph my angle. Now I'm facing the 150. I want to go 3. Right? But if I was positive, I go 1, 2, 3, positive. I don't want to go positive, right? I want to step backward. So from this 0, 0, I don't go forward, I go backward. 1, 2, 3. Put a dot there. That's D. Alright, if you want to graph a radius, a circle. So go to 2.5 and graph a circle. Alright, that's r equals 2.5, a circle. Well, what would r equals 245 be? Well, it'll be right down here. So on mine I need, let's see, this will be each by 15, 210, 235. So 245 would be right kind of in the middle. And again, you don't need these guidelines, they're just for the notes. You just have your big X's with 0, 90, 180, 270, and then just estimate these lines like before. Alright? Okay, last piece here. Distance formula. Given any 2 points, right? How do you find the distance between 2 points, right? A and D, the straight line distance on a curved graph. Alright, so how can you figure that stuff out? Well, just use this equation. So you get 0.1, 0.2, that's the distance. Just the radius, the first one squared, the second one squared. Doesn't matter which point when you're given the point is 1 and 2, just keep it consistent. Alright? So it makes no difference which one you use, just keep it consistent. Alright, so let's do, I don't think I have an example here. Let's make one up. Let's do 0.230 and a point for 150. Alright, so how would I plug it in? I'm going to pick this as my 0.1, that's my 0.2. I could have gone either way. So then P1, P2 equals 2 squared plus 4 squared minus 2 times 2. Alright. And now you just plug this straight in. Make sure if you're going to plug it all in, put these in parentheses. Alright. It's not going to matter for the positives, positive 2, positive 4, but these were negative 2 and negative 4, that would make a big deal. So plug it in as 2 squared plus 4 squared minus 2. So all that good stuff. Alright. So let's actually see what that would look like. So I'll have a 2 squared. Oops. Put in parentheses plus 4 squared minus 2 times 4. Cosine 150 minus 30. I'm plugging in degrees, so I'm going to hit mode and make sure I'm in degrees, right? I'm in radians now, so it's not going to come out. Let's change to degrees. So always check where you're at. Enter. So it's 28. Remember, it's the square root of the whole thing. So 5.292. Alright. So my distance, 5.292. Alright, so that's how you find the distance.